Hi everyone, this is Madan here, and I have come up with another very important chapter which I'm going to start it right now, and like I've already told you, probably you know that I'll be starting aldehyde, ketones, and carboxylic, one of the very important and very complicated chapters you might see it. So I hope this is going to be really easy as per my experience, and the objective is to make you understand each and every topic from the aldehyde, ketones, and carboxylic acid, and I'll be doing right from the beginning and right from the every single point you might see in your textbook. So you have nothing to worry, like if there any topic you might need to study or you have to search it on your own. So I'll be doing each and every part there. So let's start this, very important chapter called aldehyde, ketones, and carboxylic. It's your chapter 12, and very important from the organic chemistry, right? So I'm just writing a bit about, that this is your unit, right? And it's called aldehyde, ketones, and carboxylic acid. Carboxylic acid. So this is your chapter 12. Now the question is, this is the very important and very first thing you need to know is that what is a carbonyl group, right? A carbonyl group. Carbonyl group. A carbonyl group is C bonded with oxygen through a double bond. So this is your carbonyl group. Now this is a very important functional group. Why? Because this particular functional group can give a number of different compounds when it attaches itself to different situations. So there are some 7-8 compound that the carbonyl group can form. The first one is when carbonyl group is bonded to only one carbon, it forms aldehyde. Right? Let's see how this is. This is your carbonyl group. Now, if it's bonded to one of the carbon while the other side is occupied by hydrogen, this is called your aldehyde, right? Second one is that when carbonyl group is bonded to two carbon, two or more carbon, in fact. Yeah, it's a 2 carbon on either side. It forms ketone. So how the structure is? This is what the structure is. You have your carbonyl group. Now if it's bonded to alkyl group on the either side, this may be aryl also. This also may be aryl also. So if carbonyl group is bonded to 2 carbon on both sides, this forms ketone. This forms your ketone, right? Now let's talk about the third one. when carbonyl group is bonded to one carbon and one hydroxy group. One hydroxy group, this will form carboxylic group. So this is called, there you have a carbon here, but on the other side you have a hydroxy group. So this forms carboxylic acid. It forms carboxylic acid. Carboxylic acid. Right? Now this was your third one. Now let's talk about the fourth one. When carbonyl group is bonded to halogen on one side and carbon on other side. It forms acid chloride. Let's go with the structure, what they say. So you have your carbonyl group here, and on one hand you have carbon, while the other hand you have a chloride, or you have a halogen, right? Okay, let's make it chloride only. So this is called acid chloride. Also called acyl chloride. You do remember this, like several reactions, as Friedel-Crafts acylation reaction. You did it in the so many chapters, like you did it in haloalkanes and haloarenes. Then I made you go through the same, or as a similar reaction in the alcohol, phenol, and ether, right? So this is your acyl chloride. Now let's talk about the next one. The fifth one is, when carbonyl group is bonded to a carbon and an amide group. Or I should write amine group. It forms amide. So what this is like? This is C double bond O. On one hand you have an amino group here, and on other hand you have a alkyl group. So this is called amide. What this amide is, this is a very important, constituents of protein actually, or I should say amino acid. So a carbonyl group can form so many different kinds of compounds. There are more to come, right? So what next is, when carbonyl group is bonded to an alkoxy group. On one side, and carbon on other side. It forms ester. Ester is formed. Let's find out the structure. This is your carbonyl group. Now what you have an alkyl group here, but there you have an alkoxy group. Or this can also be like aryl oxy group. So this compound is called ester. This compound is called ester here. One last we have here is an acid anhydride group. I'll show you what is that structure. First, when there are two, carbonyl groups bonded to oxygen, when there are two right? So maybe I should write this as a R or AR. This is also like R or maybe AR. So if there are two carbonyl group bonded together to oxygen, they form acid anhydride. So let me define. When two carbonyl groups are bonded to oxygen, it forms acid anhydride. Right? So this is your acid. So this is how a total of maybe probably this was 6th or 7th one, I don't know. So this is how a carbonyl group is very magical, because it can change the entire properties and can result in number of different compounds when it attaches itself toward different. So this is what the magic of carbonyl group is. Now the question is, how these compound I just made you go through, they are going to be useful. See, in plant and animal body, we do know that they are protein, they are fat, they are DNA, RNA, and carbohydrates. So like these are the chemical compounds that basically are deciding what sort of biomolecules are going to be formed, especially that amide group decides your protein, right, and many more. But I would say that carboxylic group, ester, ketone, these are responsible for giving fragrance to the nature. These are responsible for giving fragrance to the nature, right? There are so many other useful compounds I would like to add, because you need to remember them, not because they are going to be in your paper, but because you have to have a knowledge about, right? Remember that vanilla, remember that, salicylaldehyde, these are, a very important compound in our day-to-day life. Probably you do know that. So I have to wind this right here, and let's see what I can do, with the next topic, which is going to be the nomenclature part here, right?